Have you ever wondered why some code runs once while other code runs every frame? Or how your game makes decisions like, if health is 0, game over? Today, we're learning the fundamental building blocks of game logic. Hey everyone, welcome back to Flow Labs. In our previous video, we mastered variables int, float, string, and bool. Today, we're learning how to control when our code runs and how to make our games smart with decision-making logic. We'll discover the difference between start and update methods, master if statements that let our games make decisions, and understand variable scope, the rules about where variables can be used. These are the core concepts behind every Unity game. Before we dive in, let's do a quick cleanup. In our previous videos, we created two scripts, one called game and the other script practice. Now that we've covered some coding basics, it's time to move forward and start building our game. To get started, we'll transfer the variable declarations from the practice script into the main game script. We'll also tidy up the log statements and remove any unnecessary comments to keep things clean and organized. Oh, and one quick fix. I'll correct the number range from 100 to 1000, which was a small mistake in the last video. Finally, let me show you how to display a message to the user, just like this. It builds directly on what we learned in the earlier videos. Now, you might notice something new in the message. The N character. This is called a new line and it's super useful. It tells the computer to break the text and start a new line, which makes your output much cleaner and easier to read, especially when you're giving multiple pieces of information at once. So instead of one long sentence crammed together, you get a nicely formatted message with each part on its own line. Simple, but powerful. Now save the file and jump back into Unity. Here, you can go ahead and delete the script practice file. We don't need it anymore. But if you look at the inspector panel for the game manager, you'll notice that the script practice file is still attached. Since we've deleted it, you can remove it by clicking the three-dot menu next to it. Also, don't forget to re-enable the game script, which we had disabled in the previous video. Now hit the play button. Fantastic! Look how cool that is. We're now providing information to the player through console messages. The game has officially started. We're displaying the range for the minimum and maximum guess, the number of attempts remaining, and a prompt for the player to enter their guess and hit enter. Let's start with something you can see immediately, the difference between start and update methods. This is fundamental to how Unity works. Think of start as your game's morning routine. It happens once when your game object wakes up. Update is like your heartbeat. It happens every single frame, continuously throughout your game's life. Let me show you this in action. We'll add some Debug.Log messages to see exactly when each method runs. Now, let's write this message inside the start method and check it in Unity. As you can see, it outputs exactly what we wrote, just once. How can we confirm that? Well, look here. The console shows 4 messages, and that's exactly how many we included in our code. Next, let's try logging message inside the update method. Save the file and run the game again. Take a look. Now the message is running every frame. It's so fast that it's already printed over 1,000 times in just a few seconds. Here's a helpful tip. If your console is flooded with repeated messages, you can use the collapse button at the top. This neat feature groups identical messages into a single line and shows you how many times that message was logged. It's a great way to keep your console clean and still track how often something is happening. Important note, be careful what you put in update. Since it runs every frame, putting too much Debug.Log code here will flood your console. In real games, update is where we check for player actions, update animations, and handle game logic that needs to happen continuously. Now let's give our code some intelligence with conditional statements, the if-else statements that let our games make decisions. An if statement is like asking a yes-no question. Is the door locked? If yes, use a key. If no, walk through. That's exactly how programming works. Let's look at an example. Here we're initializing our variable player guess to 50. Now we want to check if the player's guess is greater than 20. If it is, we'll display a message that says, "Your guess is higher." So what's happening here? To write a conditional statement, we use the keyword if, followed by a condition inside parentheses. In this case, our condition checks whether player guess is greater than 20. Then, we open a pair of curly brackets. This is where we write the code that should run only if the condition is true. Since player guess is currently set to 50, the condition player guess 20 evaluates to true. That means the code inside the curly brackets will execute and we'll see the message printed to the console. Let's test it out in Unity. Hit play, and boom. Fantastic. The message appears just as expected. Now, let's try changing the value of player guess to something below 20. This time we don't see the message. That's because the condition is false and the code inside the if block doesn't run. So how do we handle that scenario? Well, this is where the else part of the if statement comes in. Right after the if block, we can add an else block. This tells the program what to do if the condition is false. In our case, we'll display a different message. Your guess is lower. Now, when you run the game with a guess below 20, the else block executes and you'll see the new message. Fantastic. This is a simple but powerful way to perform conditional checks in any programming language. Now that we've seen how conditional statements work, let's talk about the different comparison operators you can use to build those conditions. First up is double equals, written as two equal sign without space between them. This checks whether two values are exactly the same. For example, if you want to know whether the player's guess is equal to the target number, you'd use double equals to sign. Next is the greater than symbol, which is also called closing angular bracket. This checks if one value is larger than another. So if the player's guess is higher than the target, this operator will help you detect that. Then we have the less than symbol, also called starting angular bracket. It does the opposite. It checks if a value is smaller than another. You can also use greater than or equal to, can be written as first greater than sign and equals. This means the condition will be true if the value is either greater than or exactly equal to the other. Similarly, less than or equal to, written as less than sign and then equal sign, checks if the value is smaller than or equal to the other. And finally, we have not equal to, written as exclamation mark and then equal to. This is used when you want to confirm that two values are different. These operators are the building blocks of decision-making in your code. They allow your game to respond dynamically to the player's input, making it interactive and fun. We'll use these operators whenever we need to compare values in our game logic, and we'll dive deeper into each one as we go along. But for now, let's shift gears and talk about something equally important, variable scope. This determines where in your code you can use your variables. Think of scope like rooms in a house. Some things belong to the whole house, like the Wi-Fi password. Some things belong to just your bedroom, like your clothes, and some things belong to just your closet, like your winter coats. Let's take a practical example from our existing code. Inside the start method, we've defined a variable called game status, and we're using it in a log statement. That works perfectly fine. No issues there. Now let's try accessing that same game status variable from the update method. You'll notice something interesting. Visual Studio's IntelliSense doesn't suggest it, and if we go ahead and type it manually, we get a red underline. That error message says, the name game status does not exist in the current context. What does that mean? It means the variable game status is scoped only to the start method. It lives inside those curly brackets and can't be accessed outside of them. So when we try to use it in the update method, the compiler doesn't recognize it. So how do we fix this? This is where scope comes into play. If we want to use the same variable across multiple methods, like both start and update, we need to declare it at the class level, outside of any specific method. That way, it becomes accessible throughout the entire class. Let's move the game status declaration from inside the start method to the top of the class. And just like that, boom, the error is gone. Fantastic. Now let's check it in Unity. Hit play, and there it is. Our game status message is showing up in the console. And since we've placed the log statement inside the update method, it's running every frame, which means it's printing multiple times per second. This is a great example of how understanding variable scope helps you structure your code correctly and avoid those frustrating errors. And that's it. You now understand the three fundamental building blocks of Unity game logic: start versus update, when code runs once versus continuously, if statements, how games make smart decisions, variable scope, where variables can be used in your code. These concepts are in every Unity script you'll ever write. Master these, and you're ready to build any game logic you can imagine. Next time, we'll dive deep into Unity's new input system to capture real player interactions. Until then, practice these concepts and experiment with different combinations. Hit like if this helped, subscribe to Flow Labs, and drop your questions in the comments. Keep coding, and I'll see you in the next video.